Welcome to Homework Lib.
So this is chapter 35, problem number 2. We have two antennas, A and B, and we have a point between the two where we want to have a constructive interference, and we know the frequency at which these antennas emit waves. It's given to us as 120 megahertz. And the distance between the two, the overall distance between the two antennas is 9 meters, but we don't know where this exact location P is. And we are to determine that if we have constructive interference at this point. So now for the constructive interference to occur, the difference in path traveled from the waves emitted from both antennas should be an integer of the wavelength, an integer multiple of the wavelength. So if we want the constructive interference, we need to figure out what this distance is, RA, and what this is, let's call it RB. Now, if we call RA as X and RB then is going to be 9 minus X, we want the difference in path, RB minus RA, to be integers of the wavelength transmitted by these antennas. So when that's the case, then we can plug in the values here, RB 9 minus X then equals M times lambda. So 9 minus 2x equals m lambda. Now, we know the frequency, but we don't know the lambda. We can calculate it using this equation. Wavelength times frequency equals to the speed of light. So if we are to determine the wavelength, then we divide the speed of light by the frequency that is given to us, 3 times 10 to the power of 8 meters per second, right? Divided by the frequency, but we're going to convert it to hertz. So it's going to be 10 to the power 6 hertz. In the sense, well, 1 hertz, as you know, is 1 over second. So that's where you're going to cancel out the seconds. And if you do this algebra, it's going to be 2.5 meters, your wavelength, right? So in this equation, your wavelength is going to be 2.5 meters. Now, there are different integers. So let's say m equals 0, right? This would be the central fringe. Now, if m equals 0, then 9 minus 2x is going to be equal to 0. From here, your x is going to be 4.5 meters. And then let's see what happens if m is positive 1. Then 9 minus 2x equals, right? I'm plugging in this equation to lambda, which is then equals to 2.5. Then if we solve for x here, we're going to get 3.25 meters. So let's keep doing this for other orders. So m equals 2, then 9 minus 2x is going to be equal to 2 lambda, which means 2 times 2.5. Here it's going to be 5. Then your x is going to be 2 meters. If we do this for third or fourth order, it's going to be 9 minus 2x equals 3 lambda. Lambda being 2.5. 3 times 2.5 is 7.5. Then from here, the x is going to be equal to 0.75 meters. And if we have negative 1 for m, then doing the same, I'm not going to rewrite it again. Doing the same, we're going to find the x to be 5.75 meters. And negative 2, it's going to be equal to 7 meters. And if you solve it for negative 3, then it's going to be x is going to be 8.25 meters.